Hello, welcome to Math 0070. I forget my section number, but only those of you who, well, let's see here. Actually, it's H1643 from the fall semester of 2020 here at South Campus. My name is David Grant, and this is the review for my fourth test for my class. Now, the first thing I'd like for you to do, since you're not supposed to be using calculators to do your powers and whatnot, is to make up a table where you'll have three columns, x, x squared, and x cubed, because in this test you'll be using x squareds and possibly x cubes. You shouldn't need to go any higher than 12. So if x is 1, then x squared is also 1, x cubed is also 1. If x is 2, then you'd have 4 for x squared and 8 for x cubed. For 3, you get 9 for x squared and 27 for x cubed. You'll need to fill out 4 through 11. But when you get up to 12, the x squared is 144, and x cubed is 1,728. So that will be of use to you in solving some of these problems. Right, now, you won't necessarily get the problems in this order, but they are kind of grouped together so that all the ones where you're just factoring are all together, and all the ones where you're going to solve equations for all are together. And the two word problems will be mixed in with them. So for these first ones, we want to factor as completely as possible. Now, if you remember, we had several special formulas to use and whatnot. And also, we know that since 6 is equal to 2 times 3, we'll have a choice here on this first problem, x to the 6th minus z to the 6th, doing it as either x cubed squared minus z cubed squared, which is going to end up being the best way to do this, or you could also do it as x squared cubed minus z squared cubed. But you'll end up with something that you won't necessarily be able to factor out. So this is the best way to do this particular type of problem. And hopefully this is using all sorts of different coefficients and variables and whatnot than what's actually on any of your tests. So the first thing we do is we notice that x to the 6th is x cubed squared and z to the 6th is z cubed squared. And so we'll have a difference of squares where each of our terms is a cube. So since this is a difference of squares, we'll have x cubed plus z cubed times x cubed minus z cubed. The sum times the difference gives us our difference of squares. Now, we also have the special formulas for a sum of cubes or a difference of cubes. For the sum of cubes, it'll just be x plus z times x squared minus x times z plus z squared. You'll always have the first one squared minus the product of the two terms that are cubed plus the last term squared times the sum of the two terms. That's the formula for a sum of cubes. For the difference of cubes, it's going to be the difference, x minus z, and then we're just adding all these other terms, the x squared, the x times z, and the z squared. So the key thing to remember is here to do it as a difference of squares first when you have a difference of 6 powers. Otherwise you won't be able to completely factor it. And then the next problem is a similar thing, except we just have a difference, or could have a sum of cubes. But it's not to the 6th power where you have to use formulas twice. So here, because 1000q cubed, that's actually 10q all cubed. We'll have p minus 10q, as we had over here, the difference, because it's the difference, okay, times p squared plus 10pq plus 100q squared. So here we just have a difference of cubes. Alright, for the third problem, you have 6x squared minus 11x minus 10. As I've noted over here, there's no greatest common factor. 6 and 10 both are divisible by 2, but 11 is a prime number. Its only factors are 1 in itself. So we use the AC method, which means that we multiply the coefficient of our squared term times the constant term, and then look for factors of that add up to our middle term. So 6 times negative 10 is negative 60. We start looking here, we have minus 1 times 60, but that difference is going to be a plus 59. That's not the right. Negative 260 is another pair. That difference is 28. Again, not 11. Negative 3 times 20 is 17. Again, that's not the right one. And then we look at negative 4 and 15, and the difference there is 11, but we want negative 11. So we go with the opposite. Instead of negative 4, 15, we go with 4, negative 15, and those do add up to negative 11. So we'll replace this negative 11x with plus 4x minus 15x. So we grouped the first two here. They're both divisible by 2x, so we factor that out. And we get 2x times 3x plus 2. In the next pair, negative 15 and negative 10 are both divisible by negative 5, so we factor it out. We get negative 5 times 3x minus 2. Oh, pardon me, that should be a plus 2. Getting sloppy in my old age, sorry about that. Well, I'm kind of doing this at an angle. Doesn't work out too well. So at any rate, we have 3x plus 2 as a factor of both of these, so we pull it out, and we get 2x minus 5 times 3x plus 2, and that's what it factors into. We're always trying to factor into either a monomial or a binomial. Okay. Now, this next one is off of one of our sum or difference squared. We start off with n squared plus 12n plus 36, and we notice that 12 is equal to 2 times 6, and 36 is equal to 6 squared. That fits from our formula. Since everything, this is a positive middle term, we're going to have a positive middle term here, and we'll just have n plus 6 quantity squared. The fifth problem, we start off with 36r squared plus 720. 36 is our greatest common factor. We'll divide both of those, so we get 36 times r squared plus 20. And it turns out, if we look at factors of 20, none of them will add up to 0. And so we're done. This is as far as you can go. You can pull the 36 out, but you cannot factor the r squared plus 20. Well, I guess I was jumping ahead to where if this was going to be an equation, and if we wanted to solve for r, we would need to have r squared is equal to negative 20 to get this factor here to be 0. Okay. That's the problem when you're an old hand at this. I've been doing this for, 40 or 50 years. You sometimes forget that you're jumping ahead and it doesn't really apply all that much. But the main thing is there are no factors of 20 that add up to 0. So there's no way to factor this. Okay, our sixth one, 64y squared minus 49. 64 is 8 squared, so we could factor this as 8y squared, and then 49 is 7 squared. So we've got a difference of squares, so we want the sum of the two terms, so 8y plus 7 times the difference, 8y minus 7. And that will give us, if we FOILed this out to double check it, we'd get 8y squared, and then the outside terms would be negative 56y, and the product of the inside terms is positive 56y. That adds up to 0 because they're opposites, and then we'll have a minus 7 squared. Okay. I will be online during the regular class time, 6:30 to 8, if you want to send me a message to ask about a particular question. We're starting out number 7 with 7 squared minus 25s plus 84. Okay, we've got a positive constant term, and our middle term has a negative coefficient. So that means we're multiplying two negative numbers together. So we're looking for factors of negative factors of positive 84 that add up to negative 25. Well, negative 1 and negative 84 is negative 85. Negative 2 and negative 42 is negative 44. Negative 3 and negative 28, that's negative 31. Until we get down to negative 4 times negative 21, that does add up to negative 25. So we can replace this negative 25s then with negative 4s and negative plus negative 21s. If we factor out the s out of this first grouping pair here, we get s times s minus 4. If we factor a negative 21 out of this next pair, we get negative 21 times s minus 4. We've got an s minus 4 in both cases. So we factor it out and we get s minus 4 times s minus 21. Some of you may be getting to where you just jump to this step here and leave this part out. You kind of do that in your head, but you know, if don't worry about it if that's the case, because you can always do it this way. Okay. And then for our last one, we have p squared plus pq minus 12q squared. Okay, we don't have to worry about, since our coefficient of our leading term here, the p squared, is 1, we don't have to multiply the first term and the last term. We could actually just treat this as a constant. So we look for, and we also notice that this is a negative, so we have to have a positive and a negative. And we want the positive one to be larger in absolute value, so that we end up with a positive 1 here. So we look at positive and negative factors of negative 12. We get negative 1 and 12. That's 11. Negative 2 and 6 is positive 4. And finally, negative 3 and 4 does add up to positive 1. So we replace the 1 times PQ with 4 times PQ minus 3 times PQ. Then group these together. We factor a P out of this first term here. We get P times the quantity P plus 4Q. And then we factor negative 3Q out of this second pair. That gives us negative 3Q times the quantity P plus 4Q. Again, we've got P plus 4Q in both terms, so we factor it out and we get P minus 3Q times P plus 4Q. And that's has this factored out. Okay, now you should be you know, on the lookout for the possibility though that you're not going to be able to factor anything out. But I'm not guaranteeing you that you're going to find one. So don't spend, remember when you're taking these multiple guess tests, don't spend too much time working on any particular one. If it's not working out, go on to the next one, and if you still have time at the end, that's when you go back and finish up the one that you're working on. So that's our 8 problems where we're just factoring. Our next 4 problems, we're going to try to solve the equations if it's possible. And remember, the way we do that is we try to get everything as a polynomial on one side equal to 0. We factor the polynomial, and we use the fact that if a product of 2 expressions is equal to 0, at least one of the 2 factors or more has to be equal to 0. Doesn't matter, we'll take either one. Each possibility could work. Okay. Now, so we look at these problems. 16 minus m squared is equal to 0. Well, let's look to factoring the 16 minus m squared. It turns out it's a difference of squares. So we have the sum of the square roots times the difference between the square roots is equal to 0, or 4 plus m times 4 minus m is equal to 0, which means that either 4 plus m is 0 or 4 minus m is 0. Get the constant terms over to the other side here. We get that m is equal to negative 4, from the first equation, or m is equal to positive 4 from the second equation here. And that's our answer. M is equal to 4, negative 4, or m is equal to 4. And you'll usually get two possible answers. Now, if it factored into something like 4 plus m squared, basically you'll get that m is equal to 4 twice. So there's really one answer, but it actually occurs from both factors. Okay, you'll be in another course when you learn about how that's like multiplicity 2. Okay. Now our next equation is a little more involved because we have to multiply the product of factors out first and then bring the constant term over and see if we can still factor that new expression out. So if we use the FOIL method and multiply x minus 3 times x plus 2, we get x squared. Then outside we get 2x. Inside is minus 3x. And then the product of negative 3 and positive 2 is negative 6. Is equal to 6. We haven't brought this over yet. So we end up with x squared minus x minus 6 is equal to positive 6. We change this to a 0 by subtracting 6 from both sides, which gives us x squared minus x minus 12 is equal to 0. This is similar to one we've already done. We'll notice that the factors of negative 12 that add up to negative 1 are negative 4 and positive 3. So I've kind of skipped a couple of steps here, and we know that x minus 4 times x plus 3 is going to be equal to 0, because if we FOILed this out, we would get x squared minus x minus 12. Okay, this being the case, that means that either x minus 4 is 0 or x plus 3 is equal to 0. And if we solve by moving our constant terms over, we get that x is 4 or x is negative 3. Again, if you got questions on these, send me a message in Canvas during that 6:30 to 8 time, and I'll be happy to answer your question about it. Okay, third problem. Everything's already set up. We have x squared plus 9x plus 20 is equal to 0. So what factors of 20 add up to 9? Well, that's 5 and 4. So I went ahead and worked this out the long way, so you wouldn't accuse me of jumping ahead. But it wouldn't hurt to, I figured it wouldn't hurt to do at least one example here to show all the steps. So x squared plus 5x plus 4x plus 20 is equal to 0. We look at this first pair and we factor an x out. We get x times x plus 5. Here we look at the 4x plus 20. We factor a 4 out and we get 4 times x plus 5. We've got x plus 5 as a factor in both terms, so let's factor that out. Kind of reverse our distributive property of multiplication over division, and we get x plus 4 times x plus 5 is equal to 0. So that means that either x plus 4 is 0 or x plus 5 is 0. So that means either x is negative 4 or x is negative 5. Okay. And then moving on to the last equation that we're solving. And we have, well, we don't need to multiply this out. We just need to bring the 24 over to the other side. And we would have then 5a squared plus 26a minus 24 is equal to 0. We have an odd and two evens, so there's not going to be a factor to pull out of all three terms. So we look at 5 times negative 24 and get negative 120. So we want factors of negative 120 that add up to positive 26. So we look at negative 1 and 120. You know, and you could probably know that the first two of these aren't going to work, but I just list them for completeness sake. So here we would get 119, which is not 26. Here we would get 58, which is not 26. Here we get 37, which is not 26. But if we look at negative 4 and 30, we add those together, we do get positive 26. So we're going to replace this 26a with 30a minus 4a. And I put them in that order so I can get the minus and the minus. The two negative terms together, the two positive terms together. So if we look at the first pair, we factor out the 5a, and we get 5a times a plus 6. Then the second pair, excuse me by the way for that little burp. We factor out a negative 4, and we get negative 4 times a plus 6. We get a plus 6 in both terms. So we factor that out as well. That gives us 5a minus 4 times a plus 6 is 0, which means that either 5a minus 4 is 0 or a plus 6 is 0. Over here in the first one, add 4 to both sides, you get 5a is 4. Divide through by 5 and you get a is 4/5. Or if a plus 6 is 0, that just means that a is negative 6. So this is our answer, these two possibilities. All right, now a word problem. And I discovered apparently that placemat is not all one word, although I thought it was, to be honest with you. But so I had to insert a little space there. Unfortunately, my graphics pad doesn't allow me to erase any of this, so that's why it gets kind of cruddy looking every once in a while. So for problem 13 is one of our word problems. The area of a rectangular placemat is 168 square inches. Its length is 2 inches longer than its width. Find the length and width of the placemat. Well, if we let x be the width, then x plus 2 is going to be the length. And we know the area of a rectangle is the length times the width, so we get x times the quantity x plus 2 is equal to 168. Going ahead and distributing there, we get x squared plus 2x is equal to 168. Subtract 168 from both sides so that we get a polynomial equal to 0. And we get x squared plus 2x minus 168 is equal to 0. So we have a negative and a positive They're opposite in sign, so that means we need a positive and a negative factor of negative 168. So again, I just went ahead and started off negative 1 and 168 is too big. Negative 2 and 84, 82 is too big. Negative 3 and 56, 53 is too big. Negative 4 and 42, that'd be what, negative 38, or pardon me, positive 38, that's not right either. Negative 6 times 28, that would be negative 22. I don't know why I keep saying negative here, I've got negative on the brain. Positive 22, it's not right at any rate. Then I looked over here and said, okay, 28 is 7 times 4, so if I use the negative 7, I just multiply the negative 6 by 4 and get 24. Again, 17 is not the right number. So I pull a 2 out of here, I get negative 12 and positive 14, and voila, if we add those two together, we get our positive 2x. So we replace the 2x with the positive plus 14x minus 12x. Okay, and if we look at the x squared plus 14x, we factor out an x and get x times the quantity x plus 14. Then we look at the negative 12x and minus 168. We factor a negative 12 out of there, and we get negative 12 times the quantity x plus 14. I wasn't that lucky. Okay, we've got x plus 14 as a common factor in both of our terms, so let's factor it out. Get the x plus 14, and that leaves us with an x minus 12. So if x minus 12 times x plus 14 is 0, then either x minus 12 is 0 or x plus 14 is 0. So let's scoot up here now. If x minus 12 is 0, that means x is equal to 12. And if x plus 14 is equal to 0, that means that x is negative 14. Now, how many of you have seen a placemat with a width of negative 14 inches? Okay, it doesn't make sense, right? So we throw this out as an extraneous solution. It works mathematically, but not in the real world. So that tells us that x has to be 12 inches actually. So the width of our placemat is 12 inches, and the length then is 2 inches more than that, or 14 inches. And then the 14th problem, in this case, we have the product of two consecutive odd integers is 323. Find the integers. Okay, since they are odd integers, they're going to be of the form 2n plus 1. Okay, and so we'll let 2n plus 1 be the first odd integer. The next consecutive one is going to be 2 plus that, because there's an even one in between. So if we add 2 to 2n plus 1, we get 2n plus 3. That's the second odd integer. So our equation then is going to be that 2n plus 1 times 2n plus 3 is equal to 323. So now then we multiply the 2n plus 1 times the 2n plus 3, and that gives us 4n squared. We look at our outside terms, 2n times 3 is 6n, 1 times 2n is 2n, and then 1 times 3 is 3. So we combine these two middle terms here. 6n and 2n is 8n. And then we subtract 323 from both sides. And positive 3 and negative 323 is going to be negative 320. And then we pick that negative 323 so that this would zero out. Okay. So we have 4n squared plus 8n minus 320 is equal to 0. We can factor 4 out of all these, so let's do that. We get 4 times n squared plus 2n minus 80 is equal to 0. Well, 4 can't be equal to 0. It's too busy being 4. So that tells us then that n squared plus 2n minus 80 has to be equal to 0. And I kind of jumped ahead here. The two factors of negative 80 that add up to positive 2 are positive 10 and negative 8. So I went ahead and replaced those in, getting n squared plus 10n minus 8n minus 80 is equal to 0. And we factored n out of this first pair. We get n times n plus 10. Then we factor a negative 8 out of the second pair, and we get negative 8 times n plus 10. We have the n plus 10 in both terms. Factor it out. We get n minus 8 times n plus 10 is 0, which means that either n minus 8 is 0 or n plus 10 is equal to 0. Now on the other one, where we were talking about lengths, we couldn't consider a negative distance. But there's no law that says that all odd integers, or all even integers for that matter, are positive. So when we solve this and find out that n can be 8 or n can be negative 10, we don't throw out the negative 10. That's just going to give us another pair of possible pair of consecutive odd integers. So if we let n be equal to 8, then 2n plus 1 is going to be 16 plus 1 or 17. And 2n plus 3 is going to be 16 plus 3 or 19. 17 times 19 does equal to 323. But off the top of your head, you should say to yourself, well, 17 times 19 is going to be equal to the same thing as negative 17 times negative 19. Because two positives equal positives, so do two negatives. And sure enough, if we let n equal negative 10, then 2n plus 1 is negative 19, and 2n plus 3 is equal to negative 17. So these are the opposites of the first pair that we found. And for this type of problem, you don't throw anything out. You have two possible pairs of consecutive odd integers that give you that product. All right then. Well, once again, Thursday by 6:30 I will have sent each of you your own test. The coefficients will be different. Same types of problems, but the coefficients will be different. And so you'll get those by 6:30. You'll have until 8 o'clock to finish it. And then make sure that you send me a Canvas message where you just list the numbers 1 through 14 and just give me the letter that corresponds to what you think is the nearest to the right answer for that particular problem. I shouldn't really be getting, pictures for this. I guess I'll take it. It's not that difficult. But and also again, if after you go through this, you have some questions about it, send me a Canvas message Tuesday, the 3rd. If you're not, hopefully you won't be out voting all day. But I guess I'll have to take that into account. Well, no, that's the review. We won't worry about that. So I'll answer questions during that 6:30 to 8 o'clock time, if you have any. You guys have been pretty smart most of the semester, to be honest. Kind of nice to just have a nice small class of 9 students, where at least 2/3 of you seem to have a really good idea of what's going on. And then it's next Thursday, the 5th. This coming Thursday is when we have the test. So we do that between 6:30 and 8 o'clock. And by Friday noon, you should get the results. And basically, good luck.